Maplewell is modernizing energy demand for commercial industrial buildings. We do this by unlocking demand flexibility within those buildings through the use of distributed battery storage to create energy savings, grid service revenue, and add a layer of energy resiliency. Our grid optimization and predictive control engine helps solar developers, facility managers, and distribution system operators to predict, optimize, and control peak demand within their buildings. Yeah, so for our customers, we're really seeing three key problems: interconnection delays within adding what's known as a distributed energy resource onto the grid, as well as peak demand charges within their buildings, and also just constrained by their existing infrastructure in upgrading and adding electrification within their buildings. So our solution is JANiiT, is a predictive energy management system, which is built on grid optimization and predictive control for peak shaving applications. JANiiT helps our customers deploy energy storage behind the meter, as well as for distribution system operators in a non-wires alternative, and an exciting new use case that's emerging in the industry known as community batteries. Yeah, so our core architecture, we are interfacing with real physical systems at our customer sites. And there's always an exposure to network latency or even bandwidth constraints. So early on, we developed our architecture to have a NUC device that is on site. So that's really how we got started with the Intel Liftoff program. Learning how to use Intel's hardware within the NUC format, and then understanding how to take these cloud-based models and deploy them onto the edge. Yeah, so just really the Intel Liftoff program in general has been helpful for Maplewell to help tackle some very challenging time series-based forecasting problems, and then leveraging the Tiber Cloud for training, testing, tuning of these models. And then to further add on to that, Intel has some additional hardware acceleration that's been beneficial for us to understand how we take these cloud-based models and deploy them at the edge on resource-constrained devices. So we're using, really operating at state-of-the-art in terms of taking LLMs and adapting them for time series. So part of a hackathon that we participated in a few months ago with Intel was taking the Chronos LLM that was developed by the AWS data science team, and seeing how it compared against some of the other time series-based forecasting models. And very, very impressive results. At least for our application, we were seeing a 25% increase in accuracy of our model compared to the other state-of-the-art methods.